Today we're going to talk about types of meters, types of time signatures. So really, what is meter? Well, meter is the time signature, but it's more than that. It's the way that the beats are organized and the way they relate to each other. It has to do both with the number of beats in a measure and with what beat value we have, and sometimes it matches the time signature, and sometimes the time signature can be a little bit misleading. So let's look into it a little deeper. So when we think about types of meters, meters have two components. Meters have how many beats there are in each measure. So we can think that there are 2 beats, or maybe there are 3 beats, or maybe there are 4 beats in each measure. The name for each of those is duple, and please don't write double, duple, triple, and, as you could probably guess, quadruple. So something that has 2 beats in a measure is a duple meter. Something that has 3 beats in a measure is a triple meter. And something that has 4 beats in a measure is a quadruple meter. But it's not just that, because we can also categorize them based on what the beat is like. Do we take the beat and divide it equally into 2 parts? 1 and 2 and 3 and 4 and. Or do we split it into 3 equal parts? Dot, 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 dot. So those are different types of meters. And the name that we give to the meters that have an equal half for downbeat and upbeat is simple meters. So you can think that the beat is divided by 2 in simple meters. So what is a meter that has 2 beats in a measure and the beat is divided by 2 equal parts? 1 and 2 and 1 and 2 and. Can you take a guess? How about 2-4? Or maybe 2-2? Or maybe 2-8. I think you get the idea that it's essentially 2 over x, where x equals some note value, right? 2 over whatever. Those are my duple meters. And so, the next logical step, triple meters, 1 and 2 and 3 and 1 and 2 and 3 and equal downbeat and upbeat, beat split it into 2 pieces, and there's 3 beats in each measure. Well, that would be 3-4, or 3-2, or 3-8, or, well, actually, I'm going to put a little maybe on that one. It's a kind of an exception to the rule. But basically, 3 over x, where x equals some note value, would be our triples. Quadruples, as you probably guessed, we're looking at 4-4, 4-2, 4-8, etc. 4 over something. Those are the quadruples. Now here's where the time signatures can be a little bit misleading, and this throws people off. If we take our beat and we divide our beat by 3, we split our beat into thirds, that's what we call a compound meter. And compound meters sound like da 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 da, where you get that strong, weak, weak for your beat structure. The reason it's misleading is that our system of numbers for music are all based on whole notes. They're all integers They're all within the powers of 2 when you think about our note values. Whole, half, quarter, eighth, 16th, etc. None of that can express thirds, something that's split into 3 pieces that are all equal. So what do we do at that point? Well, we have to write it a little differently. If I had something that was, I'll give you the most classic example, 6/8, which is a duple meter that is also compound. It's a compound duple. If I think about 6/8, 6/8 is really 3/8 notes and 3/8 notes. It's 2 structures with 3/8 notes each. Beat 1, beat 2. The problem is, using the system of note values that we have and using the system of counting that we have, we can't count those that way. We have to count them differently. So rather than counting each beat, because this would essentially be each beat is a dotted quarter note, instead of counting that, we count the division of the beat. We go 1, 2, 3, 4, 5, 6. So if ever you said in a music rehearsal that 6/8 time has 6 beats per measure and the 8th note gets the beat, you're right. Well, and you're wrong. And you're kind of both. Because the way we count it, we do count to 6. And we are counting 8th notes. And for a lot of people, that's enough. But in music theory, we always dive a little bit deeper. So when we're looking at this, we're actually looking at a dotted quarter note's worth of time being the beat. Because this goes 1, 2, 3, 4, 5, 6. 1 and 2 are not equal. 1 and 3 are not equal. 4 and 5 are not equal. 4 and 6 are not equal. Beat 1 and beat 4 are your strong beats in this compound meter. And all compound meters work that way, where we're actually counting the division of the beat, but you and I know that that's not really the beat. Okay, so let's break it down to nice and simple. If duple, triple, and quadruple all have 2 in the top, and don't say numerator, it's not a fraction, 2 on the top, 3 on the top, 4 on the top, then compound, which is my beat, but split into 3 pieces, if I'm thinking I'm counting each of the 3 pieces in that beat, then it's really just 2 times 3 equals 6. So all of my compound duple would be like 6/8, 6/4, something that is 6 over a note value. And the triple would be 3 times 3, 9, 9/8, 9/4, 9 over something that's a note value, 9/16, 9 whatever you feel like. Not 9/1, that would be crazy. I don't know who said that. Quadruple would be 12, 12/8, 12/4, 12 over something. Now, a second ago I said 3/8 is kind of a weird exception. Technically, 3/8 is a simple triple meter. And if I ask you what 3/8 is on a homework assignment or a test, put simple triple. But there are several parts of history in which 3/8 was used exactly like 6/8, but only half as long. It was treated like a compound meter with only 1 beat in each measure. If you want, you could call it a compound single, right? It's not usually referred to that way, but that's the way 3/8 works. So if you're ever doing a piece in 3/8, especially if it's fast, then this is going to feel a lot like this. But if for some reason it's a more contemporary piece or it's a lot slower, then 3/8 might feel a lot more like 3/4. There is some blurring between these, especially 3/4 and 3/8 when they're in really, really fast tempos. They almost feel like these. And when this is really slow, it almost feels like this. So occasionally we can blur the lines with tempo, and we can make one meter feel a little bit more like another meter. Another mistake people make is they think that, well, because 4/4 has 2 beats that are stronger than the other, that 4/4 is a duple meter. But no, 4/4 still has 4 beats. Beat 1 and beat 3 are stronger than beat 2 and beat 4, but all of those are stronger than the upbeats. So keep that in mind. We're looking at the number on top that's going to show us to finding the right answer. Astute musicians might think, wait a minute, I know a time signature that's not on that chart. And it doesn't have 2, 3, 4, 6, 9, or 12 on the top. What's that? Well, generally speaking, if it's not here, and it's not on this chart, and it has anything other than 2, 3, 4, 6, 9, or 12 on the top, then it is irregular. And it's not irregular duple or irregular triple, irregular quadruple. It is just plain, by itself, irregular. And what irregular meters are, is they're meters that the beat is divisible by 2 and 3 in the same measure. So for example, 5/8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you hear how those beats come at irregular intervals, meaning they're not all the same? Sometimes this is also called asymmetric. So the beats are not the same length as each other. That's an irregular meter. One has 2 parts, one has 3 parts. And all of these irregular meters have variations within themselves. So 5/4 could be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, where 1 and 3 are the strong beats. But it could just as easily be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, where 1 and 4 are the strong beats. In one of those instances, it was 2 and then 3, and in another instance, it was 3 and then 2. So this order can get swapped around. Sometimes it even gets swapped around within the same measure too. You could have 2 and then 3 and then 2 again. So in 7/8, there's 3 versions. 7/8 could be 2, 2, 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Or you could have 3, 2, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Or, if you want to be really crazy, you could have 2, 3, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. That's really kind of weird. So you have those alternating feelings of 2 and 3, this almost asymmetric step to it, where it's off balance, off kilter, and it makes those meters unusual and interesting and a little bit more engaging because they don't fit into the regular plan. So essentially, it's any of those that aren't. But what are some examples of irregular meters? Well, you could have 5/4, you could have 7/8, you could have pretty much whatever, I don't know, 11/16. Even something so innocuous as 8/8. Well, that seems so normal, right? But usually if you see something like 8/8, because it's not one of these numbers, it's going to be irregular. And it'll be something like 3/3/2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Or something like that. So anything here, you want 11 or 13 or 15 or 17 on the top, it's going to be an irregular meter. So this comes first, simple duple, simple triple, simple quadruple, or this comes first, compound duple, compound triple, compound quadruple. Anything that's not there is irregular. And when you're counting based on how many you count to there. But when you're writing it, more on this in a future lesson, you're counting it based on how many are here. Which is why when you see these groupings, they're going to be beamed according to how many are actually in a beat, which is one of the reasons why knowing that this is actually not the number there, but that number divided by 3, knowing that changes the way you write it, and it changes the way you perform it, and it makes you a more knowledgeable and expressive musician.